Oh, okay.
this past weekend.
Oh, okay. We were. I was marking some. Well, it was a test week about a week ago, so I was marking some tests, and let's just say that the epidemic had a impact on the students' ability to write invigilated tests. So we'll see what happens there. But anyway.
Right. So you mean it has impacted how they are writing tests?
Yeah, so they for the past year and a half they basically wrote online tests, which is the same as writing open book tests, right? And this was the first time they wrote a sit down invigilated closed book test again.
Oh, I see.
Okay. And you can see that the students aren't used to that. But anyway.
Okay, I see. All right. Okay. So
how did you did you have a meeting with Victory on?
Yes, on Thursday.
Thursday.
Yep. So he should be joining, right? I mean, this.
I just sent him a message, so I do.
Okay.
Yeah, I expect him to be joining. He has seating in the lab at the moment, so he should also be able to have. I mean, if he just comes in early enough and enters the lab, he should have good internet as well. Just wonder where he is now. Because I see he's not on Slack as well, and I don't see messages from him. Okay, interesting.
All right. So let me maybe just quickly update. On Thursday, basically we talk about how his current implementation. Okay, and he's been using the signal thing. Okay, and basically I would say that the overall logic, the structure is right. Okay, in terms of how he's thinking about doing this. But I think a lot of implementation details, okay, it's something that you will need to like get sorted out. And also, so basically my instruction for him, or I guess my recommendation was just to get it work, okay? Just get whatever design that you're thinking about to get it work. Because I do actually expect some issues to come out, okay? From the way that he's doing, but you would be like too small details to actually fix them one by one. Okay, so kind of I guess the assessment is basically a lot more actual hands-on coding is needed. Okay, to actually get the implementation to work, and yeah. I would imagine, like a really strong developer to work alongside would help. And I think Anisio is perhaps acting that role now. Yeah, but still, I think in terms of the practice, the actual implementation, I think Victory needs to be, more, supported, and also it needs to gain experience on that essentially. Okay.
Yeah, so I think what I'm there's two options there basically. The one is to get the final year student who's working on his Scriptsy to help with the implementation. I think that might, but I think the better option would actually get Alida involved in, basically with the implementation details of that.
Okay. Because go ahead.
Yeah, I think so. She'll probably have to do it after hours, but that shouldn't be a problem. And I think her software development skills is much better than Victory. So that's the impression that I got, at least. I did have a meeting with Victory on Wednesday, I think the afternoon or over lunch or something, where after we had the discussion about the signals and slots, I basically just came and said, okay, but this is basically what you're trying to do over here. Yeah, so I was actually hoping that on Thursday he had sorted that out, but okay, as you now say, there's still some implementation details over there. Yeah, I think the other thing is I think he needs to put the thing on a repository, like a Git repository somewhere, so that other people I mean, if a leader or the other student's going to help with the development, then it must be in some public repository somewhere where other people can access it and help with developing the implement or help with the implementation of the
Right.
algorithm.
Okay, a share repo, right? Share repo.
Yeah, shared repo. Yeah.
Okay. Yeah,
Where is
that's
Victory?
probably needed. All right. So
I
shall
sent it. Wait. I think here is Victory. Or not? No, not sorry. I thought it looked like he joined, but I was wrong. Yeah, it's weird.
Okay,
He
all right.
usually sends
So
some message.
all right. So I mean, you probably should receive the message already, right? From the
Yeah,
okay. All right.
from Slack. Yeah,
Okay.
I'm gonna send one on Vastvis as well.
Okay. So all right. I guess the okay.
So last week we spoke about the possibility of getting, or you suggested we get a product owner to help
right.
with that. Yeah.
Mhm.
Just trying to think where did I write that down? Here we go. Okay, cool. Yes, you said a product designer, basically someone who understands the problem, translates it to a user design. Yeah.
Right.
And then
right.
I haven't had time to speak to that other colleague of mine, but that's something I want to do this week to see if we can get access to the experts in that what do you call it, the taxi industry, so that we can get some feedback on whether this is something that is feasible to them, and they can give us input on the exact problems that they have, or the exact requirements, if I can put it like that.
Okay. All right. So okay. So I am definitely thinking, so I think we are faced with some obstacle now in terms of the overall progress. Okay, but this is something I think worth discussing a bit about. Okay, and also just something I learned this morning actually. So I'd like to share. Okay, is that Victory?
Looks like it.
Okay,
Victory.
Hi everyone, sorry about that.
Hi, how are you?
I'm all right. Good morning.
Okay, good morning. All right. So how's everything? I mean, did you have a good weekend or a pretty tired weekend?
Pretty tired.
All right.
Yeah, let me just
Okay. So okay, so maybe a quick update about what's happening. Would that be all right?
Yes.
Okay,
Yes,
all right,
yes.
thanks.
Let me share my screen quickly. All right. So again, forgive the drawings. They're a bit ugly, but I was trying to sort of just break down what was going to happen in each line of code, basically. And this is just a bit of a summary. So let me know if you can see this, the text and everything.
Okay, yes.
Yeah. So the idea is simple, the node sort of emits signal, and in this, at first I thought this was going to be the simulator, and it still is to a certain extent, but some of the stuff overlaps. So for now, we can just think of this block as a connector block. So the idea is, get the instance of N1, and this is in the connector now, and save that whatever happens. So there's a signal and then the dictionary. Save that instance and sort of append, sort of tag it as a specific signal, as maybe signal 1, and also signal 2 as well. But instead of signal 2, I think this is more like receive signal, but it's fine. So just for test. So something similar. So in the connector layer, there's like 2 dictionaries, and where we say bind, the idea is, okay, so check the what's supposed to bind basically, and is it what we want, and this can be predefined. So we can just for so the connector layer sort of acting like as that the can think of it as I think the hardware in the physical setup, and then just checking to be sure that to what we have predefined it as, like, okay, if signal one is this, just activate N2, and these are just yeah. So the node receiver, this is basically the same as N2, but I was trying to break it down a little bit, but it's fine. The same thing. So again, trying to break it down a little bit. It was quite complex to sort of comprehend, but it's all good. um, so simulator again. At first, I was gonna emit the signal at the node at the node layer, and sorry, at the simulator layer, and the idea was just to do all the connection at that layer, but then it didn't make sense because each node should have its own um sorry each node should have its own um signal emission, if that makes sense. Yeah, like its own flag or tag. So it's a simple so the idea was this was supposed to happen in its own node. So let me just move this maybe a little bit there. Right. So generate the node, emit the signals, send the signal through connector, add to dictionary, and if there's a match, basically send it to the destination, which is N2. More or less this. Let me see. And also again to just break it down to just be sure, because a lot of these things are interconnected, and I think at some point I need to create a signal at the simulator layer for the receiver. So there's like a bit of a match, but it's let me show you so at the moment the execution is a bit it's better than it was, but it's still not 100% there. And the reason why is we're still stuck at this this thread. I think we're trying to look into multi-threading as well, but it's simple. We have so don't think of it for now. Don't think of it as node to matcher. At the moment, it's just node to node, where we don't care if node one is a matcher or node two is a but it's simple. If the connector works, we can simply just apply it to any single or any type of node that has some sort of network connector. And if you notice here, so there's the node one, it initializes its ID. So let me look at the simulator. So there's the generator for node one, right? So I'm saying, okay, generate this node and activate the publish protocol, or server, or to send to specific destination. And in this destination, we have match one, and you have the port. Again, for now, port is not necessarily relevant, but in that, so when we say initialize, you have the ID and everything, the payload, and then there's the destination which we've set in the simulator, right? And in this case, the idea is to create a signal and assign the signal in this publisher to something called signal S1. And the idea is print. So I mean, in theory, I expected that if I put S1 in, if I put S1 in, this should automatically just change to S1. Right. That's, I mean, in theory, I assume that should happen, but it doesn't do that. It just assigns this S1 to this message or the payload that I returned. Again, it's a very, very strange thing, but it's fine. Sorry. So M1, um, so once that is, so the idea is, do that, and then in the fake network layer, just assign all of this that we've created. So the signal and the port and the destination. So in theory, this destination IP should be the signal, the signal of M2, which should be created on what do you call it? Which should be created in the simulator. So again, I'm still trying to work the complexity of that out. but well, I'm almost there. And in the matcher, it's basically the same thing. If you notice this, because so there should be a receiver function as well. And the idea is once this goes into the connector, so instead of binding to like an actual IP or port or that kind of thing, the idea is just create a dictionary here where it's saving all of that. It's saving, so there's a node signal, there's a payload, and then there's destination. And the idea is if this destination matches, what we have predefined at the simulator layer, for example, simply just bind that information to matcher one. And again, matcher one. So in this case, there should be like a receiver function, but the receiver, again, if I say receive, my complication is still coming from how do I find this S1, right? Because this is supposed to be some sort of universal variable. And if I say receive, receive from S1, so there's supposed to be some sort of link to the thread in memory, and which is something I'm also looking into. And once the thread is referenced or once it has been created at the signal layer, the idea is okay, just send it. But it looks like I might have to just create it directly such that if the receiver simply just listens for N1, which we would have set, it's like, but I'm still looking into that. But I think I'm making some progress, at least in terms of just making sure the structure and the flow of information is right. And once that is sorted, it's just simple, like moving that especially this connect library, just moving that and just implementing that in our actual pub sub layer or simulation. Sorry.
Okay, all right. So, all right, seems like takes a lot of effort so far, right? So, okay, all right. So, I guess Herman, any feedback?
So this looks like you've that discussion we had on Wednesday. It looks like you've basically started implementing that. If I look at the code, and you say the problem at the moment is that you're not getting the identification of the signal correctly. Is that correct?
Yes.
Okay, so one thing I do suggest is this code that you have. Do you have some kind of a shared repository like on GitHub or Bitbucket or somewhere like that, or is this only on your computer at the moment?
It's on my computer at the moment, but I've been looking at doing that as well. In fact, but I think Spider does not allow me to. I'm looking into just using this. I know there's a synchronized thing here. I just need to figure out how to synchronize to GitHub from VS Code.
Okay. So in other words, you have a Git repository, and you just need to synchronize it there. Okay, because if you share that Git repository with us, that means I could look at it myself to see if I can see what the problem is, and I also want to share it with Alida and with the final year project student so that they can also start helping with the implementation, which I think would be helpful.
Yeah, that would be really helpful, actually. Thank you. So, okay.
So, right. Okay. So, Shunyan, no, continue.
No. So, Herman, any other feedbacks?
Yeah, so when I looked at what you had over there, it wasn't, or the flow diagram that you had, or the system diagram that you had over there, it wasn't clear to me when, I think that one, approach version 2, the top one, basically. Is that what you're doing? Is that what you're doing now, or is that what you won't be doing?
So it is what I'm doing, but the flow, I think this should be at the end here, so this is more like so the emit signal is more like a feedback to N1. It's supposed to be this, so this is supposed to do something like that, and then that should go on there, and this it should simply just like come here somewhere, like something like that.
Okay,
where
so this basically assumes that signals and slots have already been created and they've
yes,
already been connected to each other.
yes, precisely.
And is that on page 3 of your slides, is that where you basically handle the so the part I'm not seeing over is this basically where you basically create signals and slots and connect them to each other?
A lot of this stuff is sort of interlinked, honestly. Uh, so the idea was at first this is what I drew, and then I tried to break it down again. But the whole purpose of all of this is just to sort of separate the roles of in terms of the software partner as to what the connector does, what the at the node layer, for example, the gen should sort of actually happen outside the node in terms of the generator. So this should happen somewhere here. And then, once the node is generated, then the node internally should emit a signal called maybe signal N1. And then this signal should be sent through the connector. And we can think of this as the connector box, where it's receiving the signal and then, adding this signal to a dictionary 1. N2 as well, there has to be some form of, storage for now as a temporary way to, store the list of maybe destination IPs. And that's why I also put generate node here, just to generate the second, the receiver node. Generate, also create node. So there should also be a send signal, which is going to act as the feedback to N1, basically. And the idea is, if once I generate my signal, add to dictionary, and in this connector, that's where the magic basically happens and says, okay, there's this request from, so the reason why I'm doing this like this, I'm not necessarily saying node to matcher or matcher to node. I'm just saying node to node, where in this code can be reusable if the roles were reversed. So if N2 was the sender and N1 was the receiver, the only difference, and I think I tried to implement that a little bit here, because if you notice, there's the generator node for node 1, generator node for node 2. The only difference is the destination for this is, this, and the destination for this is, so it's like there's supposed to be some sort of reverse possibility. Well, like node to matcher is possible and matcher to node, as long as the connector sort of does the same thing or role.
Yeah, so I guess my question is, do you create one signal and one slot for each node, or
Yes.
are you creating signals and slots each time you're sending a message?
Well, that's a good question. So it's each time I'm sending a message, actually, or, no, or let me not say each time. Each time an instance of the node is created, a signal is emitted. So if, for example, if this was 5 nodes, then 5 different signals will be generated.
Okay, each of those nodes should also have a slot, because the signal is the sending part and the slot is the receiving part, if I understand correctly.
Yes, absolutely. So in theory, and that's where this part comes in, the slot, this whole point is supposed to be the slot, where basically the what do you call it, the input into the node. So the so there's supposed to be some sort of circular, what do you call it, some sort of feedback loop happening in this simulator, and that's sometimes it sort of gets a bit complex. But we are looking into it. I'm also like in contact with Anisio as well. We spent some time on this yesterday, and the idea is, how do we sort of create some form of callback where it's just there in memory, listening for every published signal. But we are trying to, because in theory, it means we might have to create a signal here for the matcher, where now that signal sort of acts like an input into the node. Or sorry, is it input? Yeah, as as a feedback mechanism in the larger scale of things.
Okay, so because the way I think it should work is that when you create nodes, you create a signal which you will be using for sending, and the node will also have a slot that you will use to receive messages. And then when you want to send when you want to publish a message using PubSub, then basically what you want to do is you want to get that the sending nodes or the publishing nodes signal, and then connect it to the, make certain, when it basically needs to send it to a specific IP address, you basically need to get that signals, or when you connect to it, you basically need to connect those signals and slots, which allows you to then send messages. So that's the one thing I just want to make that I think if you can connect two nodes together, basically using, the binding and connecting and sending, then I think that you would have a way of simulating the way a real network works.
Okay. So from my understanding, at least, I could be wrong, just correct me, but so in simple, let me see if I can find just a simple test of this. So say I have this, right? I have this, and I want to. So the idea is I'm going to have to assign a signal to this, and there's this function doing something, and if I connect to that something, the idea is now I'm assigning this signal that has been created to this function. So it's almost like this is the input to the node, and the return, or basically, I'm basically outputting this, or this function is outputting this, and the idea is that output has now been tagged to a signal. So again, if I print N1, it's supposed to, it's only, and that's where I think this been stuck. The library is not very clear in terms of the documentation as to, because I would have assumed I should be seeing N1 as a node, or as an object in memory. But if I do that, let's say get something, right? If I do that, it's more or less something like that. But then again, it's still tagged.
Okay. All right. So Victor, here, I guess here's a bit of a feedback. Okay. I'm not sure if it's just the appropriate feedback at the moment, so you have to judge yourself. All right.
All right.
I think there are two routes from here. One is to still continue to use the signal, okay, and then try to figure out how it works from there. There is another path, however, that might work, okay, potentially. So you have to evaluate, which is just use some arrays, SQ, and then build a map to map the sender to the receiver queue, the receiver arrays. Okay, that's it. Okay, a single dictionary. Okay, do you see what I'm saying? Just build a single dictionary. The dictionary does one thing, which is give it a node ID, and it gives you an array.
Yeah.
Okay, which is that particular node's receive queue.
Yes.
Okay.
Yes,
Is that understandable?
Yeah.
Okay. And then whenever you send, just look up from the dictionary, get the queue, and push it, to the back. Okay.
Okay.
All right. Okay. Okay. This is from Nick. What be Nick？ 等一下就结束。OK， 稍等一下。
好，那我要先离开吗？还是
5分钟 ？Yeah. OK. All right. So basically, just store at the end of queue. Okay. And then whenever you are processing, okay, just loop through the dictionary, which should be easy to do. Okay. And then, just get the queue from for each node and then process the message. Is that understandable?
No, it is. I mean, I was planning to have a queuing mechanism. I mean, if I run this, the idea was, you have dictionary 1 and dictionary 2, and then the idea is there's like a waiting.
Well, no, there's just one dictionary. See?
Just one. Okay.
Yeah.
Okay.
Right now, just create one dictionary. And all it does is just map node ID to the queue. And that's it.
Okay.
Okay?
That's the
All right.
yeah. That would be the receiver queue, in other words. Yeah.
Yes. Okay.
Yeah.
So evaluate. I mean, do you understand the logic for this?
Yes, I do.
Okay.
I do.
All right. Okay.
Simply just waiting.
So please evaluate if it might be easier, okay, to do it this way versus maybe using Signal to implement. I see both as workable, okay, but just find whatever makes sense and easier for you to do now. All right.
All right. I'll do that.
Okay.
Yeah.
Okay. All right. So so hopefully we'll see a working version. Okay, tomorrow.
Amen.
Okay, I feel we are close to that now. Okay, it's just need to maybe simplify things or clarify things a bit. Okay. Yeah. And then the shared repo. Okay, maybe to set it up as Herman suggested.
All right. I will do that. I will do that today.
Okay. All right. Okay.
Cool. Thank you.
Yeah. So we'll sync tomorrow then. All right.
Yes.
Okay. And
Yeah.
so Herman, I'll have to share that with you tomorrow then. Okay.
Okay. Cool. Cool. That's right.
What we do. Okay.
you,
So
sir.
chat tomorrow. Okay. All right.
Tomorrow.
Okay.
Okay. All right. Thanks. All right. Thanks. Bye bye.
Bye.
Bye.